In this session, I'd like to introduce you to Cisco's own LoRaWAN expert, who's going to tell us about one of the most cost-effective ways to collect data and still get the support of Cisco to do it. Here's Kevin Holcomb to walk you through this important technology and some of the offerings available to you.
I'm Kevin Holcomb, a technical marketing engineer in our IoT group here at Cisco. I focus on our LoRaWAN offerings, which that's LoRaWAN for long-range sensors. And what we'll do today, we'll start with a little bit of what is LoRaWAN kind of thing. We'll start back at the beginning, what the technology is, where it's used, and then we'll dive into some use cases, example use cases in oil and gas for LoRaWAN. And then finally, we'll circle back with we'll come back with a couple of ways that Cisco can help consume that technology. So to start at the highest level, what is LoRaWAN? So LoRa, the LoRa part of LoRaWAN stands for long range, right? So we're talking really long range sensors. They're going to be sensors that don't report all the time. Right, so you're not getting like millisecond granularity, you're not transferring live video or files or anything like that over LoRaWAN, but it's great for little pieces of data that you get every once in a while, right? So think like a remote tank level reading or a temperature reading or air quality reading, something like that. The type of data that doesn't change that frequently, definitely not part of your critical control path. But for monitoring those little pieces of data every once in a while, because it's low bandwidth, but you get the really long range. It's unlicensed spectrum, right? So it's very easy to go out, set up a couple of gateways because the range is so great. And now you've got this big area where you can get, remote data about your assets. The other key thing about LoRaWAN is the battery life. So the protocol was developed, the technology was developed from the ground up with battery life in mind, right? So you're getting, sometimes you get up to 10 years of battery life depending on the type of sensor, right? You can get out of a device. So you put it out in the field, you get really long range, up to 15 kilometers in a rural environment. Usually as long as you can get the gateway up really high, as high as you can, like on a tower or a rooftop, something like that, for outdoor type use cases. As far out as you can see, just about, you'll be able to cover. Right? Usually you'll be able to go as far once it hits the ground will definitely stop the signal, but other objects is definitely propagates really well, especially compared to other types of wireless technologies. Okay, so every wireless technology or every technology in general usually has a place, right? There's a use case for everything. And so LoRaWAN kind of fits at a high level. If you look at this diagram on the right, this is kind of where LoRaWAN fits, right? So you're talking long range, but low power consumption, right? Like I mentioned before, you're not going to stream video or anything like that over LoRaWAN, but LoRaWAN fits in that, bottom right quadrant there. So you're going to get long range like with cellular, but it's lower power consumption, makes it easy to have, battery powered sensors out there for a long time. Your range is going to be a lot farther than say Wi-Fi or BLE, right? So that's kind of where the technology fits. And for sure, like in a given deployment, you're going to have places, depending on the application, that probably use all of these, right? But this kind of gives you an idea of where LoRaWAN fits relative to other wireless technologies. So the types of use cases we see this in, going outside of oil and gas, even just to give you an idea, mining, big wide areas, predictive maintenance, machine vibration, asset tracking, a lot of uptake in water and gas metering, right, for commercial and business use. Leak detection, like kind of smart building type use cases, smart parking. There's a lot in smart cities in general with LoRaWAN because you can do waste bin monitoring, smart parking, monitor air quality around a city. So a lot of usage for LoRaWAN with that. And then temperature and humidity. Right, a lot of times we use this in food processing because the range is so great, it goes through walls, right? So you can have sensors inside refrigeration rooms and monitor the temperature, right? So that gives you an idea of, if you can go through like a wall, a refrigerated wall, and go through a big giant facility, imagine what that does outdoors when you get that out in open air. these are a couple of ideas, the use cases in general where we see LoRaWAN getting used. Now, LoRaWAN, it's worked on by the LoRa Alliance, right? So that's kind of the standards body for it. And Cisco is one of the founding members of the LoRa Alliance. We've been members of it since near the very beginning. We were a founding member, right? So since the very beginning of LoRaWAN in general. And we got over 500 customers in about over 60 countries, right? So we've been in with LoRaWAN for a while and got deployments all over the world. Now, the general LoRaWAN architecture, right? This is what the architecture looks like. So you're going to have sensors on one side, and then you're going to have sensors, and you're going to have gateways. The gateways are pretty much, they're just converting what comes over the air into IP, right? So it's LoRaWAN's coming over the air over here, and then you're going to convert it to IP. At the gateway, it goes to the network server. The network server is kind of like the brain behind the operation. So the network server would be like a wireless LAN controller for Wi-Fi, or maybe a call manager for collaboration. It's kind of that central point, right? So multiple gateways. You could have 50 gateways out there. They're all going to go back to this network server. And that network server is what kind of figures out who's allowed, what gateways are allowed to connect to my LoRaWAN network server. How do I securely authenticate with them? What radio plans, what channel plans do I push down to that gateway, right? So the network server is going to do all that. And then the network server is going to figure out which sensors are allowed to be on my network, right? I'm going to create session keys and everything, so the data that goes over the air is encrypted. So that's the network server. The other function of the network server is packet deduplication, right? But because you have lots of gateways out there, multiple gateways all attached back to this single network server, this centralized network server, a sensor is not really associated with a given gateway. It's not like in Wi-Fi where you're kind of associated. If you're walking through a building, right, with your laptop, you're kind of like roaming from one Wi-Fi IP to the next one to the next one. In LoRaWAN, the sensors just send messages out. So they just broadcast them out whenever they feel like it, usually on some set interval or at a state change, but they blast the message out, and any gateway that can hear that message will hear it and report it up to the network server. It's the responsibility of the network server to figure out, oh, I've seen this message 2 or 3 times already from other gateways, so I'm going to throw these extra ones away. Right, so that's another function of the network. Yes.
I got this just popped into my head here as you're talking about that. Tell me how you secure that. Because I know in Wi-Fi, a lot of that association what secures that connection. How do we secure a LoRaWAN data point, or is it not secure and we need to make sure we design around that?
Oh yeah, it's secure. Yeah. So it's in the LoRaWAN protocol itself, there's encryption from from the sensor to the network server, right? Okay. So even let's say even we were able to like somehow snoop this line at the gateway, and we were able to sniff this and gather some data. It's even encrypted at that point. Okay. Right. It's like at that point,
that's really important.
The gateway.
And I would say I knew it was secure, but I don't know that I could have explained it the way you just did. But I know that I've had people sort of make that comment before, right? Is that LoRaWAN doesn't have all the sophisticated stuff that some of these other wireless technologies do, and so it can't be that secure. But your explanation, I think, is really, really helpful. So go ahead. Sorry, I just wanted to interject that and make sure that people got that.
Yeah. So it's definitely secure. And the security was built into the protocol itself, right? So it wasn't like the protocol existed and then somebody kind of threw in security as an afterthought. It was developed from the ground up with security in mind. And even in a lot of implementations, you'll even have additional security to what I just talked about. So a lot of times, like for instance, if you're connecting our gateway to the network server in the cloud, for instance, you might build an IPsec tunnel from that gateway to the network server, right? Which is even another level of security.
Over and above,
Yeah, and then you get the AES 128 is what's used for LoRaWAN, from the endpoints to the network server, and then there's even another encryption from the endpoints to the application server. Right, there's another
Oh,
level.
wow.
So
Okay.
yeah, and the reason that one exists is because in in the beginning of LoRaWAN, there was a lot of focus on service providers, right? So let's say I'm a customer and I'm using a service provider. The service provider probably operates the gateways and operates the network server, but I'm a company that's using their service, and maybe I don't want them to have access to my raw data. So
Yeah.
in that way, it's important for me to have the encryption from my sensors all the way to my application, right? So there's anything that has to do with the network server itself will be a network session key. That's the encryption, and that's from the endpoint to the network server. And then everything else would be an application session key, which would be from the endpoint to the application server. So yeah, a lot of security built in. But yeah, so we're kind of coming from left to right here. We've covered endpoints, gateway, network server. And then other function of a network server is, okay, I've got this communication mechanism, right? I've got this sensor data coming in. Where does it go? Is it going into OSI Pi? It's going into a data lake. It's going to some visualization application. So that's going to be the application server part, right? So now my data is going to go out of the network server. It's going to go to the application server, and that's where you actually consume the data and do good things with it. Now, thinking about the gateways, right? So Cisco has a couple of different options there. The one on the left is our IXM gateway. So that's been out for a couple of years now. That's our IP67 outdoor rated product. So that one's great for going on a rooftop, going on a tower, something like outdoors. It's IP67 already, so it can just go directly outdoors. You can plug a PoE plus, connected switch to it, and through a wired, through a cable, and it's ready to go. And then over on the right, this is our new product. So we have our IR1101 router, right? And it's modular. So it's a lot of different modules you can plug into it, like several different flavors of cellular, 5G, Cat 6, Cat 18, a bunch of different types of cellular pluggable modules you can plug in there. And now we've added the ability to turn that router into a LoRaWAN gateway function as well. So this one is great for like putting it in cabinets, right? It's IP30, so you're not going to put this just like it is right there on the top of a tower or a gateway, or sorry, a tower or a rooftop. So the one on the left, you can put directly outside. You can put it on a tower, it'll withstand the elements. The one on the right there, that's IP30. So if you put that outdoors, it's going to be inside a cabinet of some sort. It's DIN rail mountable, right? Or you could put it indoors, right? For sure, as long as the IP30 rating is okay, you could put it directly indoors. But the beauty of that one is, if you need cellular backhaul somewhere, so say you've got a remote site and you need cellular backhaul, you can do it all in that one box. So you can put a cellular pluggable module in there, and then you can put the LoRaWAN pluggable module in there, and now you've got this, your backhaul and everything right in one box. So this slide's really covering what I just mentioned about the different places you would deploy it, the ruggedization levels, and then the same thing for the PIM, right? This one does have ATEX certification. The 1101 does, and you can also do other cool things on this one, like you can host applications, right? If you want to write a custom app and host it on the router as well, you can do that. Okay, so let's think about a couple of specific use cases where LoRaWAN, these are places where we've seen it be deployed before in oil and gas, or just some ideas that we came up with. But one use case is just at general asset location and tracking, right? And the things you could be tracking there, it could be service vehicles. Right? Maybe you're in the Permian Basin and you got service vehicles out there. It's kind of not a lot of people out there, right? So maybe you want to, for safety reasons, or if somebody's truck breaks down or something like that. I've heard of places where radios don't work out there, like push-to-talk radios. It's just such a wide area. So maybe you use something like track service vehicles. You could track personnel, right? There are LoRaWAN little tags that are meant to be worn on the lanyard for instance, are placed in a pocket. Maybe you got, lone workers. So you got somebody going out to a site on their own or going out in a remote area. You kind of know where they are, right, for worker safety. And then just in general, high value assets, theft prevention, that kind of thing. All right, if you got remote areas, you want to see if something, get notified if something moves, right? If somebody moves something, or you can do like geofencing, and see if something moves out of an area, maybe you get an alert. So those are general, asset tracking type use cases. Another good use case, we see this one a lot, is tank monitoring, right? So like all these tanks that are out there with it could be oil and gas in there, it could be a lubricant, it could be some anti-corrosion chemicals, water, whatever the tank might be. Instead of having to go and visit those sites all the time to see if the material is there, you could just put a sensor on it and periodically get an update, how much oil or how much gas or chemical is in the tank, right? So that's remotely, from miles and miles away, you could get that information now. I heard this was referred to as a digital dipstick. So instead of going out and, doing the monitoring yourself, with a dipstick, you just get it remotely now. You can see it from anywhere.
In the previous example, Kevin, you had the asset location piece. I know this is big in mine sites where there's like lots of levels, but you've got some pretty big industrial environments out there for oil and gas as well. And if there's what we find is if there's quite a few people on site and there's a shift change, a lot of times some of these high value tools can be parked somewhere without necessarily it being recorded, right? So something like even a people mover or some type of forklift, it might not be exactly where you think it is, and this is a way to easily track it, right? You're not spending a lot of time looking for where it was last used. There's probably other systems as well, but that's something that we see in some industrial environments be pretty practical.
Yeah, exactly. And they'll make a lot of the location sensors, right? They're made for long battery life. So they'll do things like they'll only report, say, once a day, just to let you know it's still there, right? And the battery's okay. But once it does move, it'll start to send it a more frequent update. Right, so if you're monitoring for, looking for the location of tools or some piece of heavy equipment in a really large area, it's perfect, right? You just take a little GPS sensor, throw it on there, and you'll always know where it is. Okay, and another one that we see out there is valve position monitoring, right? So you got a giant facility with lots of different valves, and you want to do a maintenance operation, you have to go out and check the valves before that operation. And then of course, when the operation's over, you have to go check the valves again. That takes a lot of time to do. And also, if things aren't configured the proper way, maybe it's unsafe. It's an unsafe condition. So you can monitor the location of all these valves with LoRaWAN. And you can also do some wear and tear detection, right? So if you find out that something is 98, if you think it's all the way closed, but it's reporting 98% closed or 102% open, right? If fully open used to be in one location and now fully open is a little bit more rotation, right? You can start to know like, oh, that valve might be, undergoing some wear and tear. Let's go check that out. So those are some other use cases that you can do with LoRaWAN connected sensor. But the thing you'll see in all these use cases, the type of data you're getting is little pieces of information, right? Every so often, because like these valves aren't changing all the time, right? Or a tank level is not changing drastically all the time. It's the kind of thing where if you're monitoring it every 30 minutes or every 15 minutes, or maybe even every hour, there's a lot of insight you can derive from that. Okay, then there's just predictive maintenance, right? If you got there's pumps and motors everywhere, right? So you can put LoRaWAN connected sensors on there now, and get uplinks of vibration information, and so now you can look for trends over time and things like that. Maybe do predictive maintenance.
So Kevin, talk a bit about how this works, because I've always kind of thought of vibration monitoring as actually real time, transmission levels. But so this sensor, LoRaWAN sensor, because you're only transmitting every once in a while, it must have some analytics in it that basically recognizes an anomaly. Is that kind of how it works?
It does, yeah. And I have a whole slide on this one and a few more slides because there's a little bit of detail we can go into with that one. So I'll definitely cover that question about how it works and how we analyze the information it provides. Yeah, that's a good question. Okay, and another use case is just general physical security, right? You got remote buildings out there, maybe comms buildings, things like that. Maybe I want to monitor, know if there's ingress, egress. Is there occupancy in that hut there? Maybe if, depending on what the type of building is, I want to know if there's a water leak or some kind of leak out there, right? In some really remote area that I can't easily get to. Now I can kind of know where's probably, maybe somebody went to service something out there and accidentally left the door open, and now animals get in there, right? You can detect these kind of things, and it's very easy to do. You don't have to do a lot of wiring. You don't have to like send people out to install it. It's really, you take this little sensor out there, you stick it on the door, and now you know, right, if the door is left open or if anybody's entered the building. Okay, and to kind of segue into that question about the vibration sensor, I'm going to cover that as part of, I'm going to briefly touch on what we offer. We have a couple of different ways that we offer LoRaWAN here at Cisco. So one way is that diagram we looked at earlier where you pick your sensors, and gateway, and network server. There's a way where I call it the build your own approach, because you're going to pick your sensors that you want to use. You're going to buy those from some vendor. Hopefully you use Cisco gateway, right? You're getting that from Cisco. The network server piece, you can use, you can buy Actility's network server, ThinkPark Enterprise, through Cisco. We also interoperate with other network servers as well. And then there's an application server, right? But it's kind of the reason I call it build your own is, the end customer or partner and integrator kind of puts all those pieces together, does all the purchasing, makes sure everything works together, interoperates properly. So that's one model for consuming LoRaWAN, right? The other model that we have is Cisco Industrial Asset Vision. Originally, we did the build your own model. That's the way we always that was Cisco's way to kind of do LoRaWAN. What we heard from a lot of customers is it's hard to put all those pieces together, and they just want something that works out of the box, right? So what we did there, we created Industrial Asset Vision, where Cisco kind of takes that entire architectural diagram, sensors, gateway, network server. There is one, but you never have to interface with it. It's kind of hidden away in the cloud. And then we also have the visualization, in our application server. That function is also in Asset Vision. Now, so what you'll get here, we have 12 sensors today, and one of them, two of them I'll talk about in the next two slides. But so, if your use cases fit those 12 sensors, then it really is you on board with a mobile app, scan a QR code, sensor, give it a name, the sensor's reporting data, right? The gateway, you just connect it as long as it can reach to the cloud. The configuration and everything automatically happens. So this is kind of your turnkey. This is the I have assets. I just want data about the assets, and I don't necessarily want to have to be an expert on LoRaWAN. This is the model for that. Now we have customers that do both ways, right? We have some customers prefer this turnkey approach. Some customers prefer to have complete flexibility on all those pieces in the architecture, right? They want to find whatever sensors there are out there, some third-party different types of sensors, and they go that model, right? So either way, we have something to offer here with the technology. But I thought I'd show this, the Asset Vision offering as well. Yeah, this is kind of just what it is, right? So you got single pane of glass, alerting, role-based access control, that kind of thing. With that, this is what the Asset Vision dashboard looks like. And then for deploying, something happened to my icon there. But for deploying, you scan QR codes. It's very easy. Out of the box, take a new sensor out of the box, scan it. It's in the system, right? Reporting data. It's for like a 30-second process most of the time. Now we'll talk about two sensors in particular, and the second one we'll talk about will be the vibration sensor. We'll cover the question that Roland asked a second ago. But one sensor we just added to Asset Vision is we call it the industrial sensor bridge. So this one is, you can connect 4 to 20 milliamp sensors, right? Or 0 to 10 volt, or sensors that have a digital output. You can connect those into this bridge. And then every once in a while, every 15 minutes by default, this bridge is going to sample that 4 to 20 milliamp sensor, and it's going to backhaul it over LoRaWAN. And then once it hits our dashboard, we can transform the data. So rather than showing you, 7.2 milliamps, we're going to show you something PSI or tank level, some meters, something like that. So we actually transform the data, because when you onboard the sensor, you tell us that 4 milliamps means this and 20 milliamps means this. And we go ahead and transform the data for you. And you can also export that data out of Asset Vision. You can go northbound into other applications through MQTT, for instance, to go into your own applications. So that's the industrial sensor bridge. And of course, that opens up a ton of use cases, because there's 4 to 20 milliamp sensors out there for just about everything, right? Air quality, tank levels, everything. So that's one thing, one sensor we added. And then the second one we just added is the AV251 vibration sensor. So this one goes back to Roland's question earlier. So the way the sensor will work is, by default, once an hour, it's going to wake up. It's going to take a bunch of samples of the vibration, right, in the time domain. And to be really specific, it's going to take 800 samples at every axis, right? Now, back to LoRaWAN not being something you're going to transfer video or large files over. There's no way you would send that many messages over LoRaWAN. You'd backhaul, 800 samples per axis. So what we do on this sensor is it's going to process that data at the edge on the sensor, right? It's going to wake up. It's going to take the samples. It's going to process those, and it's going to report a bunch of statistical derivations and the summary data, right? So you're going to get like acceleration RMS and peak. Velocity RMS is probably the most important one for these frequencies that we're measuring here, up to 1 kilohertz. And then it's going to do displacement, and then a lot of statistical derivations, right? Skewness, kurtosis, standard deviation, crest factor. So now, because we're processing it at the edge and we're backhauling just a small bit of data over LoRaWAN, it works perfectly, right? So the sensor is going to wake up, report all this information, go back to sleep for an hour. Hour later, it wakes up, does the same thing again, reports it, goes back to sleep. So you're not going to get the kind of granular, you're not going to get the constant data flow of vibration. But what you will get is, over time, you'll be able to see this device, this motor normally works this way. And now I can see it trending up, or maybe across a threshold line, right? So that gives me an indication now that, something might be messed up with this pump or this motor. Let's send somebody out there to look at it. And maybe when I go out there and look at it, I connect the high dollar vibration analysis equipment, right? I'm looking for harmonics and higher frequency things, and I'm trying to really diagnose what the problem is. So this tool here, the AV251, is not really going to diagnose the problem for you, but it's an inexpensive way to have an indication. And so you can use this now to deploy maybe on motors that you normally wouldn't have any visibility into. Right, because you're really, really important once you probably have something on already, but there's a tier below that where maybe you don't have anything today really, or maybe you have periodically, once a quarter or something, go around and hook some equipment up and take some measurements. Right now you can have kind of ongoing visibility into that and get an indication that something's messed up before it actually fails.
That was Kevin Holcomb, who took you through some of the options you have to operationalize LoRaWAN. You can jump right into the next session of our Virtual Energy Summit by clicking on the next video. Take care.